Hello and welcome. This is part 4 of a video series created for students studying CFD analysis of a quadcopter. This part will help you understand your simulation. You will also learn how to check if the simulation is converged and how to interpret your results. You can also run your simulation on a GPU if you have access to GPU machines. To find the GPU option, you need to go to Enterprise in the capability level. Then, under the Solver option, you have access to the GPU solver. Whenever you start your run, the residuals will be plotted in one of the windows. Residuals measure the imbalance of the current numerical solution and must be descending and have small values. Besides residuals, you need to plot the quantity of interest, which we covered in the previous part. The plots must stabilize to consider your simulations as numerically converged. Last but not least, you must check the overall mass in your model. To find the fluxes, go to Results Fluxes, click on Mass Flow Rate, and then you can find the inlet and outlet here. In this case, we don't have an inlet, it's only the outlet. Then compute. The net values should be small and within an acceptable range. You need to perform some post-processing and compare the results with verified data if you have it. There are several options for post-processing. One of them is contour plots. Contour plots are under Results. Before creating the contours, you must create surface plane, which you will use in contours and vector plots. To create a new plane surface, right-click on Surfaces, then New and select Plane. Select XY plane and rename it as Plane 0. Set Z distance 0.04 meter and click Create. To create a new contour plot, double-click on Contour Plot, and you will see this window. First, you need to define the variable, for example, velocity and then velocity magnitude. Then, you need to define the location. You can choose the surfaces you already have, or you can create new surfaces in your model. To create a new surface, open this menu and choose a plane. Let's say we want to create a plane at the center of the drone. Create it, scroll down, find the plane you created, click Save, and Display. During the contour plot creation, you can also include your mesh. Let's say we want to include the walls of the drone. You can also change the color of the surfaces here. This contour plot shows the velocity around the drone in a plane located at the center of the drone. Another point is to exclude the global range. When the global range is activated, it shows the mean and max values in the entire domain. However, for a specific surface plane that you are visualizing, you can exclude the global range and use auto range, which shows the mean and max in that specific location. You can also name your contour plot for better reference in the future. Now create another contour for velocity at XY plane, select Velocity Magnitude, and select Plane 0. Now uncheck Auto Range, and set the velocity range between 0 to 30 meters per second, and click Save and Display. You can create another contour plot for pressure or wall shear stresses on the drone's walls. To find the wall shear stresses, go to Wall Fluxes, then Wall Shear Stress, and then select the location. Save and display. Now let's create pressure contour for walls. Select Pressure, then Static Pressure under Contours of, then select Drone Walls. Now uncheck the Auto Range, and set the range from -722 pascals to 655 pascals and click Save and Display. You can also create velocity vectors, similar to contour plots. You can name the vector plot, choose the variables for the vectors, velocity, and select the surface. For example, choose a surface passing through the propellers to show the rotation and how they interact. You can change the style to arrows and scale down the size of the vectors. Click on Save and Display to display the vector plot. Another option for post-processing is creating path lines. For path lines, you can choose the rotor walls, set a number for the path, enable the draw mesh, and save and display. This will show the flow streamlines around the propellers and how they rotate and interact with each other. As part of post-processing, you can also perform some computations. Go to Results, then go to Surface Integrals, then choose area-weighted average of the pressure or wall stresses over the propeller walls. compute, and the numbers will be printed in the console. Similarly, calculate wall stresses over the propeller walls. You can perform similar computations for the forces. Define the direction of the vector you want to check the forces for example, the z direction, then choose the wall zones and print. You can also perform analysis for the moments. For each one you need to define the correct moment center and the correct moment axis. The moment center is the axis origin you defined for each rotational zone. You can also perform more post-processing by creating plots, scenes, or even animations. Thanks for watching this video series.